Well, one of the things that we do with these orbiting platforms is we try to understand the living planet, where things are growing, where things are not growing, and how it changes. This very colorful image that you see right here is the Florida Everglades. Now, this obviously is a false color image, right? There's no, the colors aren't real, and it's almost abstract. It's a little bit hard to see, but the area that you're seeing here is tens of miles across, and the different colors represent different densities of grasses. The Everglades actually flow, water is flowing south right here where the shadow of my hand is moving. Then Florida Bay is right there where the water enters the ocean. Let me give you a few other examples. First of all, here's one of those images from an orbiting weather satellite. Again, now you can imagine I'm the weather person telling you if it's going to snow or so forth. The reason that those satellites are out at that distant orbit is so that we can take very frequent images, okay? So that we can track those storm systems as they're moving. In fact, on this image, you can see 3 large tropical storm systems approaching North America. So we've got hurricanes coming in for a landing. And then here's a close-up of that image. These, even though we're looking at the whole planet, we can't actually zoom down to see enough detail so that we can see where these storm systems are moving. This is an interesting image. It's a combination of data from a weather satellite and data from other satellites to give you a global view. But do you see that band of cloud right there? This is what we call the intertropical convergence zone. So the Earth gets more the equator gets more direct sunlight, so the surface of the ocean is heated more than the other areas. So that creates convection, where air is heated and rises. And when that happens, the water vapor condenses, so it rains a lot. That's why it rains more on the Earth's equator, and that's why the Earth's tropical rainforests are all in the equatorial zone. You can see it in action right there. Here's an interesting picture. These are the Canary Islands here. This is called a vortex street. What happens is this is a northerly wind, so the wind is coming from the top to the bottom. Okay? And there's a thick deck of clouds, as you can see, but when the air gets around that obstruction, it creates these vortices. In this case, just a pretty picture, but you can also, it's used to understand how air moves around in the atmosphere. Here's an interesting picture. Now, you see in the center here, this is northeastern U.S., and again, it's going to be stupid, but obviously that's not visible from space. People do ask. These borders were added later. And you see all this stuff? Yes, thank you. Really? It's my job to, you know. Okay, you see all the bright white stuff. That's cloud cover. But do you see this cloud in the center? There's a different color. What is that? What's that?
Smog.
Smog, good guess, but actually no, it's close. You're getting there.
Yes.
Dust, you're even getting closer. It's a particular kind of smog or dust. So no, it's something you can actually see with your eyes. Oh, a sandstorm. Okay, no, it's actually coming from Quebec. It's smoke from forest fires. So what was going on here is that there were pretty severe forest fires and this plume of smoke. And you see the edge of the plume right here. There was just a northerly wind that was pushing the cloud out of the way and carrying that smoke. And one of the things, you're going to see a few other pictures of smoke. One of the things we're learning using the satellite perspective was we're learning how important fire is to the global ecosystem. Fire is a very important process that changes things and how things are exchanged between the surface and the atmosphere. Here's another neat picture. This is difficult to figure out the geography, but we're not looking straight down. We're looking at an angle. So this is what we call an oblique image. So you see at the top, that's the edge of the Earth. So if I were floating in space, instead of looking down at the Earth, I'm looking at an angle like this. Okay? And north is to the left. You're looking at the Great Lakes. This is Lake Superior here. Okay? Here's Lake Michigan. The city of Chicago is right where I'm pointing with my shadow. This is the state of Michigan right here. What's going on here? This is the infamous lake effect snow. So again, there's a wind coming out of Canada that's picking up that moisture from the Great Lakes and then is dumping that moisture downwind. In fact, southwestern Michigan, I looked it up, on this day got 11 inches of snow right there. And happens all the time in that part of the world. Here's a really neat picture of a typhoon. This is not from a weather satellite, but from a sensor on board the Terra spacecraft actually returned this, and we can actually see details in the eye of the storm and in the surrounding belts. This sensor wasn't designed to do this, but it just happened to be able to take this picture. Here's a neat picture. Okay, this shows, again, the presence of vegetation or changes in vegetation. This is Mount Taranaki in New Zealand, the North Island of New Zealand. Now, this circle was not added. It actually looks like that. What that circle is the boundary of a national park. What they did is back in the 50s, they declared this is going to be a national park. And the boundary of the national park is the mountain peak and a radius of a certain distance. That's your national park. So inside the park, you've got forest cover. Outside the park, it's mostly agricultural uses. The day before this Landsat 5 image was collected, there was a light snowfall. So out here in this area, you can see the snow from space. But in here, the snow is in between the trees, and the trees cast shadows. So that's what you're seeing there. Now these protected areas are also, a lot of people are trying to understand and track changes in protected areas because we're starting to understand that different areas, whether they're national parks or they're reserves or whatever, are important because those are the places that, for better or worse, are less altered than they were centuries ago. Okay, here's the Yucatan Peninsula. Now you see now follow the shadow. See where I'm drawing with my point of my, there's a line there. You see there's a darker color here and a brighter color there? Okay, another quiz time. What is that line? Why, and again, it's real. I didn't add this, okay? Why is there this straight right angle here where it's dark color here and bright color here? What do you think? And this is just to give you a little bit more interesting background. This is from the MODIS sensor on the Terra spacecraft. This sensor was designed to look at different kinds of land surface, different changes in land surface. What would explain that? Oh, wow, good guess. Yeah, meteor impact, because the Chicxulub meteorite impact was right here. It was 65 million years ago, but no, good guess. Positive reinforcement is what we, yes, in the back.
There would be some kind of material under there that would be different from the soil, maybe like concrete or...
Yes, there is something different. It's not under the soil. It's actually over top. Because with these kinds of sensors, we cannot see into any soil. The thing that you're seeing is whatever that light from the sunlight just throws it right back. Okay? Give you another hint. This is the border between Guatemala and Mexico. What it is difference in vegetation. Okay? The rules are different in the two different countries for how much tree cover you're allowed to remove and how much tree cover has to stay. On the Guatemalan side of the border, there's more standing trees, which cast more shadows. You know, when you're standing in a forest, you don't see as much sunlight because it's darker, right? Whereas when you're in an agricultural field, the sunlight's, you know, you can see it more. Okay, same thing, we can actually see that difference all the way from space. Here's an image from a sensor called Vegetation on the SPOT satellite. This is all of India right here, and the different colors show different densities of vegetation. Now, vegetation is the focus of a lot of work in remote sensing because it's so important for understanding how sunlight is either absorbed or reflected on the surface of the Earth. Vegetation, of course, grows, uses photosynthesis to get bigger, and it absorbs certain wavelengths of light, but it also reflects certain wavelengths of light very strongly. And we know those properties, so we build the satellite sensors to detect those different wavelengths so that we can see where vegetation is growing and where it's not. Well, we can also look at geology. Here's the Grand Canyon in northern Arizona. The center darker area here is where it's a little bit more forested. Here's an example of two different sensors looking at the Kamchatka Peninsula. And actually, that submarine base was located right about there. This is in the Russian Pacific. On the left is an image from radar data showing topography. The different colors show different altitudes. On the right is how it would look to your eyes. Now, I know it's a little bit hard to see, but you see it's a little bit darker in the center here? That's actually volcanic ash. It's a very volcanically active area. So you've got a little bit of ash covering over the snow and the ice.